Okay, welcome to Financial Computing 2. In Programming Prep and Financial Computing 1, we concentrated on the Python programming language, which is an interpreted language that's quite easy to learn and has an enormous number of very powerful modules available for it. So you can relatively quickly write code that does very useful things involving statistics, machine learning, plotting, so on and so forth. In Financial Computing 2, we're going to have an intensive introduction to the C++ programming language. C++ is perhaps the second most important language to know well in the financial industry, especially for quants. C++ is used for applications that require a much greater speed than Python programs provide. In fact, the Python interpreter itself, so-called CPython, which is what most people use, is written in the C language, which is a somewhat older but very high-speed language on which the object-oriented C++ language is based. NumPy also is written in C or C++, not directly in Python itself. Now, Pandas, as another example, is written directly in Python, making use of NumPy, and Pandas, although it's extraordinarily powerful and easy to use and flexible, does have a reputation for being slow. So our focus here is going to be on speed and on the difference between a so-called compiled language, which is what C++ is, versus an interpreted language, which is what Python is. We're also in C++ going to have much more direct access to the underlying hardware of the system, which Python, in some sense, protects us from, or in another sense, prevents us from directly accessing. Okay, so everyone's first C++ program is this Hello World program that simply displays Hello World onto the screen. Let me demonstrate this right away. I'm going to pull up my Ubuntu Linux window. I have Ubuntu Linux installed on my Windows 10 machine. Here I have a terminal window that has a shell prompt, a bash shell prompt in it. If I type ls, that will list the files that I currently have. Hello is my compiled program. I'm actually going to remove that. And hello.cpp is this code file shown here on slide 2. I'm actually going to remove that as well. And now I'm going to create that file from scratch by using the VI text editor. You're welcome to use any development environment that you like. VI is very widely available, very popular in Linux, not very easy to learn. So there are a lot of other editors or development environments that you might prefer. Here I'm going to say VI of hello.cpp, cpp, and in here I will type my code. So / file hello.cpp, pound include angle bracket iostream int main open close paren open curly std : cout double less than and then string hello world exclamation mark new line character return 0 and a closing curly brace. Okay, so I have now successfully typed in my source code for the Hello World program. I'm going to save that. Now I have the hello.cpp file. I can look at that in a Linux environment by saying more of hello.cpp. And actually, you can use more in MS Windows as well in a command line terminal. There it is. Now I'm going to use the G++, the so-called GNU C compiler, the GNU C++ compiler, and let me show you which version I'm using. Any recent version of G++ is fine. Okay, so I have version 7.4.0, which appears to be a couple of years old, but that's okay. And to use it to compile my hello.cpp file, I'm going to say g++ hello.cpp. That's it. So it's compiled. When I do ls now, the default name that the GNU C++ compiler produces for the executable program is a.out, which stands for the assembler output file. I can run this by saying ./a.out. Okay, / means to execute a program in the current directory whose name is a.out, and sure enough, it prints hello world onto the screen. That's not a very convenient name for my code file whose name is hello.cpp. So usually what I will do is say g++ -o hello. -o means create an output program file named hello instead of a.out, and then give my code file. Now it's possible to give multiple code files if I had multiple code files in my program, but I only have one code file, so I'll just say g++ -o hello of hello.cpp. There we are, and here is my hello output file. I no longer need a.out, so let me remove it. And now I can run hello by saying /hello. There we are. So I have successfully created, compiled, and executed my first C++ program, the Hello World program. Well, let's dive into that in more depth. The very first line of code here is a comment. That is, everything from this // to the end of the current line is simply ignored by the compiler. It conveys meaning to a programmer who's reading this file, but doesn't convey any information directly to the underlying compiler. In addition to the // style of comment, there's also the /*, eventually followed by */ form of comment. Here's an example of that kind of comment here on slide 3. Most of the time, people tend to use the // style of comment because // is easy to type and it's very easy to understand where the end of the line is. The advantage of /*/ is that you can actually have a comment in the middle of code or at the beginning of some code, whereas with // you would not be able to do that. Okay, so C++ provides these two different styles of comments, everything from // to the end of the current line, also everything between /* and *//. Multi-line comments are often written by using a /* followed by multiple lines of comment followed by a single */ at the end. The next line in our hello.cpp file is what's called an include directive. A directive is a line that starts with a £sign or sharp sign or hash mark or tic-tac-toe board. There's a whole bunch of terminology used for that character. Most C++ programmers that I'm acquainted with refer to that as the £sign, so they would call this the #include directive. And what this directive is doing is to include or pull in a copy of a so-called header. Technically speaking, compilation of code occurs in 3 phases. There's a pre-processing phase in which these so-called directives are handled. Then there's a compilation phase in which the human-readable text of the source code is converted into machine-readable binary code. Then the third phase is what's called linking, in which the executable binary code of your program is linked together with underlying necessary library facilities and so on in order to create an executable program. Basically, include is a copy and paste operation. That is, when I say include of IOStream, literally the preprocessor goes out and finds a file whose name is IOStream and pulls in an entire copy of that file in place of the #include line. You could manually type in the entire contents of the IOStream file, but it's hundreds of lines long, so for obvious reasons you would not want to do that. Okay? Now, the reason that we have to have the include of IOStream is that later in our program, there are these words std and cout, and there's this symbol, this operator double less than sign. Those are only meaningful to the compiler if the contents of the IOStream header has been included. A very common mistake early on in your C++ programming career is to forget your #include, and then you'll get error messages from the compiler saying, I don't know what std is, I don't know what cout is, blah, blah, blah. All right, so just get in the habit of putting include of IOStream at or near the top of every code file that you create, and that will enable user output to be displayed and eliminate a lot of syntactical complaints from the compiler. Okay, so we've taken a look at the comment that's telling us the name of the file, and we've taken a look at the include directive that's telling us about input-output stream facilities. The remainder of this file is a definition of a function called main. Okay, every legal program in C++ has to have exactly one main function defined as a top-level function. It is defined as a global function, not as a member of some class. Now, when you run a program that's written in C++, the first thing that happens is that global variables, global objects, are created and initialized in memory. After the global data has been created and initialized, the main function is then called. And so in this particular example, we have not created any global variables or global objects. So as soon as the program starts running, the main function is called, and what the main function does here is to display hello world to the user screen and then return a 0 value. Okay, so on the right side, I have switched back to my Ubuntu window with my bash shell running in it. And here are my source code file, hello.cpp, and the compiled program file. There's the source code. If I run the compiled program, /hello, we see that hello world is displayed on the screen. I claim that return 0 is also passed back to the system, but where is that 0 exactly? Well, how you display or how you see that return value from main depends on the kind of user interface that you're using. In the bash shell, there is a special variable named $? That you can look at with a command called echo, which simply displays its arguments onto the screen. And there I see the 0 that came back from the hello program. Let me prove that, well, or at least demonstrate, it's not exactly a proof, but let me demonstrate that that is the return value that comes back from the program. I will edit my hello.cpp file, and let me change that 0 to some other integer value. So I'll change 0 to 12, let's say. Let me save that file. I will compile this modified file. Let's just look at it to make sure. There's hello.cpp. I've changed the 0 to a 12. I'm going to say g++-o hello of the hello.cpp code file. Now I'll run hello. I see my output on the screen, and if I want to look at the exit code that came back, that is the return value from main, there I have a 12. Okay, so this value that comes back from main in the context of the Bourne shell of Ubuntu, of Linux or Unix, is referred to as the exit code or the exit status of this program. Okay, so let's now decompose this main function into its parts. I'm going to switch back from Ubuntu to my PowerPoint presentation. As we said, every valid C++ program has to have exactly one top-level main function. And every function definition, including main, has two parts. There is the declaration part which specifies how to call the function. In this case, the name of the function, what values you have to pass into the function as arguments, and what kind of value the function is going to return to you when it's done. And then there's the body of the function that describes what the function does. And the body of the function is contained in these so-called curly brace characters. Okay, so the declaration part has to give the name for the function. In my case, that's main, obviously. Also, there has to be a parameter list for the function, which is contained within parentheses. Now, this main function does not expect to receive any arguments passed into it, but the parentheses are nevertheless required, so I just have an open and closed parenthesis to tell the compiler that main is a function that I'm defining. In front of the function name is the return type for the function, which in this case is int, for integer. This function is returning an integer value, an int, back to the system. And int is an example of a so-called keyword. That is, it's reserved by the compiler and only means the integer data type, the int data type. Okay, so the function name, the function parameter list, and the return type are the three required parts of any function declaration. There may be some other stuff that will appear in that declaration line as well that we'll discuss as we get to it. Now, the body of the function is a sequence of 0 or more statements. The statements are simply executed in order, one after the other. It's possible for a function body to be empty and have 0 statements within it. And the body is enclosed in a pair of what are usually called curly brace characters, although like the pound sign, sharp sign, hash mark, the curly braces by some people are called braces or curlies or curly brackets or squiggly brackets. I'll just tend to call them curly braces. Okay, so in our function body, we have the two required curly braces, and then we have two simple statements. The first statement is executed to display hello world on the user's screen, and the second statement is executed to return from the main function and return this value of 0 back to the system. Okay, and this slide repeats what I just said. Now, breaking down the output statement in more depth, the first part here, std::cout, this is what's called the standard output stream object. It is an object that is associated with your character-oriented output terminal. And when you insert or write a string of characters into that standard output stream object, those characters appear on the screen. The double less than symbol is the so-called put to or insert operator. And cout is the object on which that put to operator is operating. The argument passed to that operation is a string, hello world. Now, of course, we've talked about strings in Python, and we've also talked about the \n in Python. We know that the \n is the so-called new line character. In C++, strings are only contained and always contained in double quotes. You don't have triple double quotes. You don't have triple single quotes. You can use single quotes around individual characters, and we'll see that later. But if you want to create a string of 0 or more characters, you have to use a pair of double quotes for that. As in Python, the \n, the so-called new line character, displays usually as a carriage return line feed pair. At the end of that statement is a semicolon. And in C++, the semicolon is the statement terminator. Every so-called simple statement has to end with a statement terminator, a semicolon. Okay, so in other words, what this output statement does is to simply write the sequence of characters, HELLO, comma, space, WRLD, exclamation mark, followed by carriage return line feed to your terminal. Now let me flip back to my Ubuntu terminal window again so that we can see what happens if that new line character is left out. Notice that my shell prompt is at the beginning of the line. The default shell prompt is a $ symbol and a space. And after that prompt, I can type my ls command to list my files, for example. Let me edit hello.cpp with vi. Let me change the 12 back to a 0. And let me eliminate the new line character from this string. Okay, so I've gotten rid of the \n from that string. I will save this and compile it. When I run this program, now when I hit the enter key to the shell, that will display, that will cause a carriage turn line feed to occur so that the output of my program will appear on a line by itself. But then notice that because there is no new line at the end of that string, that my shell prompt, the $ and the space, comes out immediately afterward. Okay, so unlike in Python, where you often just sort of get a new line by default because of the development environment that you're using, here in an Ubuntu Linux terminal, or any Linux or Unix terminal, if you're running a C++ program and you forget your new line character, then the prompt is going to come out immediately at the end of the output of your program. Okay, so let me restore that new line character. Put the \n back in here and re-execute. Now I can, rather than retyping that, I can use the up arrow to get that compile command back and execute the command again. Okay, so now I'm back to having a new line at the end of my output. Okay, so the second statement in here is return 0. And we see that that causes the value 0 to be passed back to the system. And we've seen that if we're using a Linux or Unix system with a shell such as the bash shell, there's a special variable $? That we can use to see that value. On other systems, or with other shells, there are other conventions. Okay, so that's quite an enormous amount of detail for this tiny little program. But all this terminology that we've discussed and all the parts in here are going to be necessary to get right and will enable you to communicate with other people doing C++ programming so that you will know what they're talking about and vice versa. Okay, so here on slide 14 is an example of what I already went through live on my Ubuntu interface. Now, it turns out, as a special case, that you don't need the return statement at the bottom of main. Main is the one and only function that does return a value. Specifically, main is returning an int value, where it is permitted to leave out the return statement. And what will happen is that a value of 0 will get sent back by default from main. 0, by the way, is how a C or C++ program typically indicates success back to the system. If you pass back a 1 or a 2 or a 12 or something like that, that usually indicates some kind of failure. All right, so let's confirm that that's true. Let me edit my program. And eliminate the return 0. I'm going to save this as hello3.cpp. That's the name of the file as indicated in this comment here. So I'll save that as hello3.cpp. Now I've got my hello.cpp file and this new hello3.cpp file without the return. Whoops, I should have changed the comment. Let me be careful and do that. since I'm going to make this available. Okay, and now let's compile it. Okay, well, I just all right, I edited the wrong file, so let me fix both of these now. All right, so this one is hello. And this one is hello3.cpp. All right, so we got that fixed. So hello is good, and hello3 is good, and hello hello3.cpp is good and does not have the return statement. Okay, we're finally getting there. So now let me compile this guy. My output program name is going to be hello3. Hello3.cpp is the source file. And even though it does not have a return statement, I still get back a 0 by default. Now, any other function that returns a value, an int or a floating point number or something, must have a return statement of the appropriate kind of value. Only main has this default of value 0 if you leave out the return statement. And that's actually for historical reasons, because when C and C++ were being standardized, it was discovered that most even very highly skilled C programmers were very lazy and left out the return statement at the bottom of main. So rather than have that be an error, they just decided, okay, well, we'll have that be a special case. We'll consider that to be success, and we'll consider that to be equivalent to having a return 0 at the bottom of the code. My own contention, my own preference, is that if you want to return 0, you should take responsibility for saying return 0 rather than leaving it out and just leaving it out. If you just left it out, it might look to somebody else looking at your code, even if they understand the rules, that maybe you just didn't really think about success or failure of your program. Okay, now totally unlike Python, where indentation is critical, where we have this obnoxious line continuation rules and so on, C++, like most other modern programming languages, is a so-called free format language. And that is only the order of the tokens. And by tokens, we mean things like words like main, literal values like 0, symbols like the double less than symbol. Only the order of these tokens matters, and their line position, indentation, etc., doesn't make any difference at all. This is not true of preprocessor directives like pound include. Those do have their own special rules, and they do need to be properly formatted. But ignoring these directives, in our case, if we just look at how the main function is defined, then the line position and indentation of all of this stuff makes no difference whatsoever. And in fact, all three of these programs on slide 17, that is, all three of these function definitions, are completely equivalent. Here is a main function that's formatted in a conventional manner. But actually, if you look at version 2 here, we have exactly the same tokens in exactly the same order. We have int, followed by main, followed by open parenthesis, followed by close parenthesis. Now the fact that the close parenthesis on the next line doesn't matter. Followed by an open curly brace, followed by std, followed by double colon, followed by cout, and then double less than, and then the string hello world. Now the string is a single token. You can't split a string across multiple lines by just hitting the enter key in the middle of the string, let's say. So the string is a single token, and then we have the semicolon for the statement terminator and the closing curly brace. So that is the same tokens in the same order as our first version, And in fact, you can cram the whole thing onto a single line. And here, the only required space character, sorry, let me erase all this highlighting here. The only required space character is this space character right here, separating the token int from the token main. If that space character were not there, then you'd have this single token int main, which doesn't mean anything to the compiler. It would actually mean int main is the name of the function, and the function doesn't have a return type, so you just get complaints about that. We do have another space over here within the string, which of course needs to be there if we want the string to display a space in that position. But otherwise, we've just crammed all of the tokens in this program onto a single line, and that works fine. Let me just demonstrate that that all works. Okay, so we've got 3 versions of main here, v1, v2, and v3. I'm going to just hammer these things in, and then we'll take a quick look at them. Okay, I'm back. So I've created these 3 files, main v1.cpp, which is normal, if you will. I have had to do the inclusive IO stream so that the standard : cout and the insert operator would make sense to the compiler. There's main v1. Here's main v2, which is very weirdly formatted. Works fine, but you should be fired if you write that. And here's main v3, in which everything, as far as the function definition for main, has been crammed on a single line. If I compile each of these, they work fine. All right, so here's main v1, and we'll do main v2. And main v3. All good. Okay. Okay, so as I said, Python is very unusual among widely used programming languages nowadays in having a more or less fixed format. Most languages are like C and C++. That is, they are free format, and they just require the tokens, the basic words and symbols and operators and punctuation symbols, to be in a correct order. The very simplest legal C++ program is just these 6 tokens. Int for the return type from main, then the name of the function main itself. Then we have an empty parentheses for our empty parameter list, open and close parenthesis, which are 2 tokens, and the open and close curly brace, which again are 2 tokens containing the empty body of code. If I create this thing, and I'm going to cheat slightly by giving this thing a comment, but here's our code: int main open paren close paren open curly close curly, and this will compile. And it will run. It produces no output, but it does return 0, so it succeeds. Okay. Now, in the notation here, std : cout, cout after the : is the object that we're writing information into, or that we're putting information into. And std in front is the namespace, in some sense the library, that the cout object belongs to. We are almost exclusively in this course going to be using objects and data types from the standard library, which is what the std namespace is about. The double colon is called the scope operator. I like to pronounce it the member of operator. And so this entire chunk of notation here, std : cout, if you read that from right to left, which we're going to be doing quite a bit of in understanding data type declarations, if you read that from right to left, you can read it as the cout object that is a member of the standard namespace. Why do we have namespaces? Well, our programs, as I say, are going to be using facilities from the standard namespace. But if you are working with purchased libraries or downloaded free libraries of C++ code, each of those libraries is going to have its own namespace so that the object names and type names and global variable names contained within that library do not conflict or clash or collide with names in the standard namespace or names in other namespaces. Now, in our class, as I said, we're only going to be using standard namespace facilities, and it can be very annoying to have to type std : over and over and over again in front of every class, every object, every variable that belongs to the standard library that you want to use. In order to avoid having to use that std : notation everywhere, you can put in this magic line using namespace std, semicolon, it's a statement, and the semicolon is the statement terminator, after your include directives, but before you start defining your code. Okay, now this is somewhat controversial, and you might find yourself working as part of a group that insists on never using namespace, and that's fine. But in our course, and in particular in my slides in presentations, it's going to save me a lot of space by having this one line using namespace std at the top of each file, as opposed to having std : showing up all over the place elsewhere. All right, so if we use the using namespace standard line, our first program gets modified to look like this. And let me make a copy of hello3.cpp named hello4.cpp. And I'll modify that file, hello4.cpp. Okay, and in here I'm going to say using namespace standard, and that enables me to get rid of the std : inside the code. All right, so I'll write and save that. We'll compile this. The output program name is hello4. Hello4.cpp is the source code, and hello4 displays hello world and succeeds. Okay, so there's hello4.cpp, in which we have used using namespace standard, and we have also not used return 0. Okay, so you can accuse me now of being inconsistent, and that's fine, because I claim that it's perfectly fine to use using namespace standard, because if you have things that conflict with standard names, that's your fault and you should fix it. On the other hand, I also claim that you should say return 0 if return 0 is what you mean. So this, I guess, is one of these style arguments that you can have and waste your life yelling at other people about. Anyway, there we go. So that's the end of our first program. The simplest program basically just consists of a main function with the include of IOStream. Optionally, you can use using namespace standard so that you don't have to say std : in front of your cout. And in this case, we're just displaying the string hello world with a new line character at the end. All right, so that's that.